Assalamualaikum warahmatullahi wabarakatuh and good day. So in this video, we're still in the method of transformation, and then I will show you when the function of hy is decreasing function, then how is it? Okay, so in previous video, you have your function of y is increasing function. Okay, so here, if your function of y is decreasing function, then the inverse function of u is also decreasing function of u. Okay, that is, if your u1 is less than u2, then the inverse function of u1, which is y1, greater than y1, which is the inverse function of u2. So you can see this is the difference. Okay, when you have increasing function, y1 is less than y2. But when you have decreasing function, your y1 is greater than y2. Okay, also as shown in figure 6.9. So you can see here, okay, this is your y, this is your u, so this is your y1, okay, here. So you can see your u1 is here. All right, so here you can see that your y1 is greater than y2. Okay, because of this function is decreasing, so you can see like this is your y1, this is your y2, isn't it? So you can see that y1 is greater than y2. So that's why here you can see that your hy is less than u1. Okay, it's the same as the set point such that y greater than equal inverse function of u1. Okay, so that's the difference here when you have decreasing function. So it follows that for u equal to hy, okay, this y function as shown in this figure, so the probability of u is less than u, then your y is greater than inverse function of u. Or in other way, if you want to find the density function of u, it will be 1 minus distribution function y. Okay, because this is different from previous. Okay, but you must understand the concept of greater than and less than too. And then in order for you to find the density function of u, we will differentiate as usual with respect to u. Okay, but if you look here, you will get negative value here. All right, so if we again use the simplify notation, okay, we simplify the notation, and then you will get this equation. Okay, for the decreasing function of u, the density function of u will be like this. So you can see here, when you differentiate, you will get negative, but here we'll take determinant. Okay, we take the value only, the positive value. All right, so actually it is not necessary that hy be increasing or decreasing, and hence invertible. Okay, it can be both. Okay, for all values of y. So important here, the function of h ni, okay, this function h ni, okay, need only be increasing or decreasing for the values of y such that density function of y greater than 0. So the set point of y, which is greater than 0, is called support of the density of function of y. So if y equal to inverse function of u is not support the density function of y ni, so then the inverse function of y ni, the inverse function equal with 0 lah. So these results are combined in the following statement. Okay, so this is the summarize lah. Okay, let y have probability density function of this one. So you know we have y, random variable. This random variable has this density function. Okay, so if function y is either increasing or decreasing for all such y that the density function is greater than 0, then your u or equal with function y has this density function. Okay, so that's mean you still have this one, the inverse function of u, and then you differentiate this one, the inverse function, you differentiate with respect to u. All right, then you get this one lah. So basically it's similar with previous. Okay, but in this case, you must understand it's decreasing. So in order for you to find the probability ni, either you use this one or like this. Okay. Okay, now look at example 6.7, page 313. Okay, let y have the probability density function given by this one. So you can see that this is the density function of fy. Sorry, this one. So you can see that 2y, and then y is between 0 and 1. So the question asks you to find the density function of u equal with negative 4y plus 3. So if you look at this equation, you can see that the intercept is negative value. So when your intercept is negative value here, it means the function is decreasing. Okay, so you can see that your density function, okay, this one of fy is greater than 0 because your y is between 0 and 1. Okay, the function of interest, this one which is u just now, is decreasing for all y because you can see the intercept is negative, and hence for all y between 0 and 1. So if u equal to negative 4y plus 3, then in order for you to get h inverse function of u, you will get 3 minus u over 4. And then when you differentiate this inverse function, you will get negative 1 over 4. Okay, so you can see that this one is negative 1 over 4, which is less than 0. Thus, okay, in order for you to get the density function of u, you will have determinant of inverse function of this one lah. Alright, so basically you will have 2 because we have the density function of here 2y. So 2 is 2, y is given or you find here 3 minus u over 4, then times with determinant, not determinant, it's a positive value of this one which is 1 over 4. Then you simplify this one, you will get 3 minus u over 8. Alright, and then similar for this one, in order for you to get the limit, okay, you just bring out to the left and to the right ni. Finally, you will get u is between negative 1 and 3 and 0 elsewhere. Okay, so the step is similar. So you can see lah. Alright, so note, okay, notes here. If you want to use this method to find the distribution of UHY, you should be very careful to check the function of this one. Okay, either increasing or decreasing for all y in the support of Fy. Okay, this one you can see from this equation. Okay, the limit. Is it positive or not? Okay, and then you can see this one. Do you have intercept slope? Do you have negative slope or what? Okay. If it is not, the method of transformation cannot be used, and you should instead use the method of distribution function. Okay, so that's very important notes. When you look at the question, okay, sometimes they give you information, use transformation method, then you use. If they didn't mention which method to use, this notes is very important lah. You must understand when to use the method of transformation. Okay.